Okay, guys, we need to discuss two more market failures. So let's consider all our goods. As we know, good can be rival or non-rival, and at the same time excludable or non-excludable. Before, we during our 9 classes, we discussed only private goods. Private goods, they are rival and excludable. Example, easy, I don't know, Apple or everything that you consume by yourself. Why it is rival? You compete with each other. Why it is excludable? If you consume your Apple, nobody can consume it at the same time. So then, on the opposite side, we have non-rival goods. We do not compete to consume this good, and non-excludable. No one can be excluded from the consumption of this good. And these goods we call public goods. Example of public goods, easy. Also, it is all that our government does for us. For example, traffic light or bench or something like that. Then here, non-rival good, but excludable. What that means? That means that we do not compete with each other for consuming this good. That means that if I consume this good, the utility of other guy will not decrease with my consumption of this good. So, and it is excludable. That means that not all people can consume this good. We can exclude some people from consumption. And the example for such good is, is our lecture. You you do not compete with each other while you are listening to this lecture, but only your group, only your program can listen to this lecture. Nobody else can. So example lecture at HSC. And we call such goods club goods. So that means welcome to the club. And the last, this good is rival, we compete. So the utility of other guy will decrease while I'm consuming this good, but nobody can be excluded from the consumption. We call such goods common goods. Common goods. And here we have tragedy of commons. You know this, when you have some common resource, I don't know, common source of water, yes, and if more people consume this water, that means that water goes down to the ground, and it is more difficult to consume for you. So here we will write down each resource, common resource. We will see this example with common grace. So, okay, today we will speak about public goods and common. I will erase this. And we will do problem 3. No, problem 2. On class 10. Let's read. Two neighbors that live in the same condominium condominium. Think of installing an automatic fire suppression system. Let F denote the functionality of this system. The higher the value of F, the greater the probability that it will detect and stop the fire on time. Their marginal private benefit from the system's functionality is given by marginal private benefit of the first guy out of this fire suppression system is 200 minus F. Marginal private benefit of the second guy is 100 minus F. Suppose that they can choose any value of F that they want, and the marginal cost of increasing F by 1 unit is constant and equal to 220. So marginal costs equals to 220 constant. The neighbors simultaneously decide on how much money each of them wants to contribute towards the fire suppression system. Simultaneously decide on, let's say, F1, how much the first guy will contribute, and F2, such that F1 plus F2 will be equal to the amount of this public good. Point A. We should prove that the situation where each neighbor contributes nothing in this situation is Nash equilibrium. So let's see. We understand that they will consume this fire suppression system as a public good. Why? Because this fire suppression system as a good, it is non-excludable because they live in one condominium, and non-rival. We do not increase the utility of the other guy while we are consuming this fire suppression system. So F is our public good. And we should prove that with such marginal private benefits and marginal costs, the equilibrium situation is when nobody contributes. Let's see this on the graph. Let's draw private benefits and costs. Here will be the amount of the public good of fire suppression system. Then marginal private benefit of the first guy, 200 minus F. Marginal private benefit of the first guy, here 200, here 200. Here everything that we count in dollars. Then marginal private benefit of the second guy, 100 minus F. And marginal costs are 220. They are constant. And from the graph, you see that there will be no contribution from each side. Why? Because how each guy will decide to contribute or not. So easy. They simultaneously decide and they think only about themselves, as always. So they make equal marginal private benefits and marginal costs. So here we see that we have no equality of marginal private benefits of each guy and marginal costs, because marginal costs are higher than marginal private benefits for each unit consumed. That means that equilibrium situation will be that each guy will contribute 0. So how to write down this? In equilibrium, do you agree that marginal private if marginal private benefit of the first guy equals to marginal cost, that means that he will contribute something greater than 0. But if my marginal private benefits less than marginal costs of production, that means that I will contribute 0. And we see this situation here. Same for Second guy, marginal private benefit of the second guy equals to marginal cost. That means that he will contribute something positive. But if my benefits, marginal private benefits, less than marginal costs, that means that I will contribute 0. Let us solve this. On the graph we see this, but let us prove analytically. So marginal private benefit of the first guy, 200 minus F1 minus F2. Where you see here is public good, which consists of contributions of both, equals to 220 from this F1 greater than 0. And if 200 minus F1 minus F2 less than 220, then F1 star equals to 0. Let us solve this. So in this situation, let us find F1. F1 star equals to minus 20 minus F2. But this equation will never be greater than 0. It is less than 0. So we will not have such situation when F1 greater than 0. You see, minus 20 minus F2 for each F2 less than 0. So here, no. Let's check second situation. F1 here equals to 0. When it will be, okay, minus 220 less, no, minus 20 minus F2 less than 0. You see, because F1 equals to 0. I put F1 as 0. This is okay, yes? That's true. Minus 20 minus F2 less than 0, that's true. That means that in such situation, with such private benefits and costs, the contribution of the first guy will be equal to 0. Good. Same for second guy. Same for the second guy. Let's write down. 100 minus F1 minus F2 will be equal to 220. And in this situation, second guy will contribute something positive. And if his private benefits less than 220, then he will contribute nothing. And check this situation. You see that in the first row, minus 120 minus F2 equals to F1. But this F1 should be greater than 0, but minus 120 minus F2 cannot be greater than 0. It is less than 0. So we do not have solution here in this row. So our solution is in the second row. Let's check, put instead of F2 0 and check. Minus 120 minus F1 less than 0. That's okay. So optimal contribution of the second guy will be 0. So Nash equilibrium will be contribution of the first guy is 0, contribution of the second guy is 0. Because it is too costly to buy this fire suppression system. And the amount of public good will be equal to 0. When they simultaneously decide on how much to contribute to buy this public good. And that's a problem, because they need this fire suppression system, but if they simultaneously decide on how much to contribute, they will not buy any amount. So let's solve point B and see what will be the Pareto efficient allocation. What is the amount of the public good that will be optimal for society point of view, from point of view of our two guys. So on point B, we should find Pareto efficient amount of public good. Let's say F with wave. We solve it as in the first task with externalities. Pareto efficient allocation is efficient for society in total. Our society right now consists of two neighbors. So what we need to make equal: marginal social benefits and marginal social costs. Marginal social benefits should be equal to marginal social costs. Marginal social benefits consists of marginal private benefits of the first and the second guy. So marginal private benefits of the first guy plus marginal private benefits of the second guy equal to marginal costs. Okay, let's make it put our numbers. So this will be 300 minus 2F will be equal to 220. And from here we will find the amount, the Pareto efficient amount of fire suppression system of this public good. You see that this will be equal to 40. And you see that it is greater than in the equilibrium with when they simultaneously decide on how much to contribute without government intervention. So here we see the problem that if they simultaneously decide, here is the problem of underinvestment. It's typical problem of public goods. That's why all our public goods, almost all our public goods in our country are provided by the government, not by people. They do not always simultaneously decide on how much to contribute for this public good, because it's not efficient situation. So here's the problem of underinvestment. How to solve it graphically? What we did, we sum up marginal private benefits. So for each unit, for each unit of fire suppression system, we sum up marginal private benefits. So for example, if F is equal to 0, marginal private benefits of the first is equal to 200, marginal private benefits of the second equals to 100. So the sum marginal social benefits will be equal to 300. Let's put it here. 300. Then, if fire suppression system amount of fire suppression system equals to 100, then marginal private benefits of the second equals to 0, and marginal private benefits of the first equals to 100. So we make vertical sum of two graphs, and this will be marginal social benefits. This is marginal social benefit, yes, and we equalize it to marginal cost, and then we find Pareto efficient amount of public good. This F with wave equals to 40. And you see from the graph how much our society loses from underinvestment. This is the difference between marginal costs and marginal social benefits, this area. This is dead weight loss. And we can calculate it. Why this is the dead weight loss? As I explained, when we in our Nash equilibrium do not buy this fire suppression system, that means that we save costs of production, this rectangle, but at the same time we lose benefits, social benefits, and the loss of social benefits outweighs the save of total costs, and this difference is deadweight loss of society. You can calculate deadweight loss as the area of triangle. It's 1/2 multiplied by 80 multiplied by 40. It's 1060. Yes. Here 80, here 40. Yes, yes. So this deadweight loss from underinvestment is the problem of public goods, the problem of such market failure. Then, point C. In point C, suppose that marginal cost of a unit of F drops to 160. So marginal cost right now, 160 instead of 220. Prove that the situation where neighbor 1 pays for 40 units and neighbor 2 pays nothing is Nash equilibrium. Is this equilibrium Pareto optimal? So let's see on the graph, as always. We understand even with such marginal costs, one of guys will not contribute, and I think it's logical that this amount of public goods will also not be Pareto efficient, but let's see on the graph and prove it analytically. So marginal private benefits of the first guy, here 100, here 100. Marginal private benefits of the second guy, 200, 200. And marginal costs now 160, it's here. And now you see that marginal costs equal to marginal private benefits of the second guy, where here he will contribute F2 equals to put 160, he will contribute 40, yes. But marginal private benefits of the first guy always less than marginal cost. So he will not contribute anything. F1 star will be equal to 0. And that means that total amount of public good when they simultaneously decide on contribution is 40. Let's solve graphically. Let's find graphical Pareto efficient allocation. What we need to do? We need to find marginal social costs. As you remember, it's the sum of marginal social benefits. It's the sum of marginal private benefits of our two guys. And they are the same. 100 plus 200, it's 300. Start from here. And then vertical sum. This is marginal social benefits. And you see that the cross of marginal social benefits and marginal costs are to the right than in the Nash equilibrium situation. So F wave, we need to count it, will be greater than 40. So our Nash equilibrium allocation amount of public good is not Pareto efficient. And how much we lose? Let's see. This difference. We save costs, yes, but we do not earn benefits. Here is also underinvestment. So this triangle that we lose is deadweight loss. Now let's prove everything analytically. So one more time. Let's consider the first guy. His marginal private benefits I reversed, yes. Okay, never mind. Here can be marginal private benefit of the second, here or the first. Consider the first guy. 100 minus F1 minus F2 is less than 160, and that means that F2 in this situation, optimal contribution will be equal to 0. Check this. Let's do it faster. Check this. Minus 60 minus F1 is definitely less than 0. Minus F1 is definitely less than 0. That's true. That means that optimal contribution of the second guy will be equal to 0. Let's consider the second guy. 200 minus F1 minus F2 will be equal to 160. And in this situation, when we find the equality of private benefits and costs, here we will have contribution of the first guy greater than 0. Let's check. 40 minus F2 equal to F1. So this is the optimal contribution of the first guy. Okay, I reversed everything, yes. So here F1, let's say that this is the first guy, and this is the second guy. Here is the first guy, the second guy, it was before. And here will be the second guy, here the first guy. And let's check. Here will be F2, here will be F1. Let's change indexes. So what we see that in Nash equilibrium, contribution of the first guy will be equal to 40 minus F2, and contribution, it should be greater than 0, and this is true only if F2 less than 40. And F2 equals to 0. And this is true only if F1 greater than minus 60. That's okay. Solve this, you see, put F2 equals to 0 into F1. So Nash equilibrium will be contribution of the first will be equal to 40, contribution of the second will be equal to 0. Check that F1 greater than minus 60, that's true. Check that F2 less than 40. 0 is less than 40, that's also true. So this is the set of optimal strategies such that no one wants to deviate from their strategies, from these contributions. So what else? That means that total amount of public goods will be equal to 40 plus 0, it is 40. Only the first guy will contribute. And we understand why, because he needs this good more. Yes, you see marginal private benefits of the first guy is greater than for the second guy. What about Pareto efficient allocation? Let's do it fast. Marginal social costs, marginal social benefits should be equal to marginal costs. Marginal social benefits, we sum up marginal private benefits. This will be 300 minus 2f equal to new marginal cost, 160. And from here we'll find that Pareto efficient amount of public good is how much? 70. And it is greater than f star equals to 40. So we see here the problem of underinvestment. And that's why we have deadweight losses. You can calculate deadweight losses by yourself. I showed you how much society loses because of underinvestment. And you see this problem appears because the second guy needs this public good less than the first guy. But even if he did not contribute to the public good, he will consume this good. because it's non-excludable. Yes, and that's the problem of public goods. What's next? Let's see. Try to do point D by yourself. You can check the next time. Then let's move on and do number 3. Number 3 is about common goods, tragedy of the commons. Common goods, they are rival, but non-excludable. And here is also the problem. Market failure. Let's see. A village has 5 residents, each of whom has accumulated savings of 100. So, number of people in the village 5, and income of each is 100. Each villager can use this money either to buy a government bond that pays 10%, or buy a year-old sheep, send it onto the commons to graze, and sell it after 1 year. The price the villager gets for the 2-year-old sheep depends on the quality of the fleece it grows while grazing on the commons. That in turn depends on how many other sheep are grazing on the same piece of land. So let's write down. So they can, each of these villagers, they can invest money into the bond, which give them 10%. That means that in a year they will have 100 plus 10%, 110 in a year. Then, second option, to buy a sheep, 1-year-old sheep, and then in a year to sell this 2-year-old sheep. The selling price of the sheep in a year depends on the number of sheep in this common piece of land. So more sheep is in this common land, their nutrition is worse. Then you will have a lower amount of sheep in this common land. So here is the problem of tragedy of commons. Let's write down this table. Number of sheep in the piece of land. 1, 2, 3, 4, 5. And here's selling price in a year. Selling price 117, 113, 111, 109, 107. So more sheep is in the common land, lower the selling price, because these sheep are how to say, they compete with each other for this grass. Yes, not like this. Then the villagers make their decisions one after another, and their decisions are public. So, make decisions one after another. So it's like sequential game. Yes. Point A. If each villager decides individually how to invest, how many sheep will be sent onto the commons, and what will be the resultant net village income? So they decide individually how to invest. So their decision is to invest in bond or in sheep, to put their money in bond or to buy a ship. Yes, this is the decision. And if we know that they decide one after another, it's sequential game. We know how to solve it from using backward induction from the last out of 5 villagers. Yes, so we will use this backward induction. Sequential game. So solve from the end. So let's consider the fifth guy. If other four guys before him bought the ship, is it equilibrium situation or not? Let's write down fifth. If ship. What that means? That means that if all four guys before him bought the ship, and the fifth guy now is buying a ship, then each of them will have 107. Yes? In a year. And that is lower than 110 if they will invest in bond. This is bond. This is ship. And we see that this is not equilibrium situation. Fifth guy will not invest in ship. So that means he will choose bond. Then move back. Fourth guy. If ship. And all other before him will choose to invest in ship. That means that all of them with 4 ship will have 109 instead of 110 if they will invest in bond. So that means that fourth guy will not invest in ship, will not buy ship. He will put money in and invest in bond. Move back. Third guy. If he will invest in ship, and 2 other guys before him also invested in ship. So if we have 3 ship in the common land, each of them will have 111 in a year. 111 when they will sell a ship in a year is greater than 110. So this third guy and guys before him will invest in ship. Each of these 3 guys that bought the ship, they will have 111 in a year, because their decision influence the income of other guys also. This 111 is for all 3 guys if we have 3 ship in the common land. So our equilibrium situation that we have 3 ship and 2 guys invested in bonds. So total income if they independently decide one after another will be 3 ship with 111 from each, plus 2 guys invested in one and in bonds, and they have 110 in a year. And this is how much? 333 plus 220, 553. This is total income of the village. Yes. Then our task, point B, is to find socially optimal number of ship. how many sheep should be on this common land from the society point of view, so operating efficient amount of sheep. So let's see what we should find. We should maximize social welfare, social benefit. Let's see. If we have 1 sheep, 2 sheep, 3 sheep, 4 sheep, 5 sheep, then let us count net benefit, not total benefit, yes, but net benefit. What extra money we will have in a year. So selling price, net benefit. Here is 17, here 13, here 11, here 9, here 7. You can also calculate with the selling price, but I think this number is easier. So, and what we will have, we should count social net benefits, yes, for each situation. Social net benefits, how much? So let's see. If we have, consider 1 sheep in the common land. If we have 1 sheep in the common land, then 4 other guys invested in bonds, and they have net benefit 10, yes, 10 extra dollars in a year. So social net benefit will be for 1 guy 17 for his sheep, plus for 4 guys 10 that they invested in bond. So social net benefits will be 57 if we have 1 sheep in this common land. Next, if we have 2 sheep in common land, 2 guys will have 13 net benefit. This will be 2 multiplied by 13, plus 3 other guys will have 10 because they invested in one. Then this will be 56. Next, if we have 3 sheep, then we have 3 multiplied by 11 plus 2 guys invested in one. This is 53. So you see, before we had total income 553, but total net income 53. Yes. Here, but you understood that it will be decreasing, but anyway, let's count. 4 multiplied by 9 plus 1 multiplied by 10, this will be 46. And here, everybody invested in sheep, 35. And social planner, to find socially optimal number of sheep in the common field, it maximizes social welfare. So maximal social net benefit is 57. Yes. And that means that Pareto efficient amount of sheep in the common land is 1 sheep, only 1 sheep. Let's write down this. This is maximal. And conclusion is Pareto efficient number of sheep is 1. Why is it so? Why we have, when they decide independently to each other, why we have 3 sheep? But it's the explanation is the same as in externalities. When we decide to buy a sheep or not, we think only about our net benefits and our costs. But when we buy a sheep, we influence badly on other villagers. Yes, because when we put our extra sheep into the field, the net benefit, not only our net benefit, it decreases, but net benefit of other people, of other villagers with their sheep also decreases. And this is the problem, the tragedy of commons. Let's write down this. So now we have social net benefit. Social net benefit. equals to 57, and it is less than net benefit, net total income 53 that we have in point A. And why is it so? Let us write down. As each villager ignores the fact, as each villager that when his sheep is led out to graze, on the common land, it reduces net return from other people's steers. Explanation is so the key moment is the same. While why we have this market value, the loss here not 57 but 53. Why we have the loss of social welfare is explanation is the same as in externalities, because we think only about ourselves, not about other people, benefits and costs. So for you to think, number C, point C, if government will charge the price for grazing the sheep, the price P for grazing the sheep, for grazing. What will be the optimal price such that total income of our villagers will be maximized to max total income? Price for grazing. So if you decide to have a sheep, you need to pay this price to the government. So think about this. Use the table, and if somebody will do it, we will check it in the next class. So, okay, that's all about these two problems about market failures. Now we finish our micro course. The next class we will start macroeconomics. Yes, and we will have 10 more classes about macroeconomics. So thank you. See you next Tuesday. Bye-bye.